All right, today we're looking at AP and GP. And also, you know, AP stands for Arithmetic Progression. So we're looking at Arithmetic Progression. And GP is for Geometric Progression, right? All right, so let's look at the AP, Arithmetic Progressions. Let's say we're looking at 1, 3, 5, 7, and 9, and so on in that fashion. How we'll know that this is what we call AP or an arithmetic progression is that we look at the terms, we subtract the first from the second or the second from the third. So we'll subtract this from this, we get a 2. If we subtract this one from this one, we still get a 2. If we subtract this one from this one, we get a 2. And if we subtract this one from this one, we still get a 2. So each time we realize that we subtract if we subtract the first from the second, we get 2. If we subtract the second from the third, we get 2. Or the third from the fourth, we get 2. So we realize that there is what we call a common difference. All right, so we have a common difference. Yes, we have a common difference. And the common difference is 2. So if you have any sequence that you're seeing a common difference between the terms, then it is called an arithmetic progression. Now this would have been our first term, so let me write down this. This is our first term, we'll call it A. All right, so A is 1. So if you look for the second term, we are going to have, so this is the first term. For the second term, we will have A plus 2, we get 3. And if we look at the third term, let me put it out here, we will have A plus 4, which is actually 2 times that. We'll have A plus 2 times the difference, all right, which is 2 times 2, all right, because 2 times 2 is 4 plus 1, that's 5, all right, so we end up getting that, which is 5. And if we look at the fourth term, we're seeing where we have A plus 3 times the common difference, and we see 7. The common difference is 2. So this is 1 plus 6, and that would have given us a 7. So 1 plus 6 would give us a 7 because it's 3 times the 2, D is 2, 6, 7. So what we're seeing now is we're able to come up with this as a general form, where we would say the first term is A, all right? The second term is going to be A plus D, which is the common difference. The third term is simply A plus 2 times D. The fourth term is A plus 3 times D. So you could see then that this formula, if you look at this, the fourth term, look at this part. So fourth term is A plus 3D. Third term is A plus 2D. The second term is A plus D. And then for the first term, there will be no D because there wouldn't be anything to find a common difference. So basically, that is arithmetic progression, and it goes on and on, all right? And then, so you will see that the first term is A, and then depending on which term we end up, you can see that it is always 1 less. So if we go as far as to say, what about the nth term that I don't know about? It is still going to be A plus, but it's going to be 1 less than n, because you could see this is 1 less than 4, this is 1 less than 3, this is 1 less than than 2, because this is the second term. So for the nth term, we're looking at 1 less than n times d. So it's going to be a plus n minus 1 times d. And this is the general formula to find the terms that we have. Depending on what term you're dealing with, you're able to come up with its little formula. So this is AP. Now let's look quickly at GP, which is geometric progression. Now for the geometric progression, we'll have stuff like, let us say we're looking at, we're looking at 1, 2, 4, 8, 16, and it goes on in that fashion. We would now see that this is my first term, A. But before we go there, if we look, we'd see that it takes 2 times this to give you that. 2 times this to give you that. So if we're looking at these, look at how we are progressing. Look at how we are progressing. We're looking at 2 times this to give you that, 2 times this to give you that. So everything is being multiplied by 2. 2 times this term give me the other term. 2 times that term give me the other term. 2 times this term give me the other term. So we're seeing for this one that we're actually seeing a common ratio between them. We're not seeing a common difference, because if I subtract, if I say this minus this, or this from this is 1, this from this is 2, this from this is 4. So I'm not seeing a common difference, but for this we're seeing a common ratio, something that multiplied by the first term that give the second term, something that multiplied by the second term to give the third, and the same thing multiplied by third to give the fourth. We're seeing a common difference between these terms. So if this is, say, A, let's say we say the first term is A is 1. All right, so we're looking at the second term is A times R. All right, because R is 2. So you would see that you're actually getting a 2, because it's going to be the common ratio. The common ratio is 2. So we said R is 2. So A times R is 1 times 2, which is 2. And then now A times R square will give us the next one. So if we look at it, we're talking about 1 times 2 square, we will get 4. And then the fourth one will get AR to the third power. So it's going to be 1 times the common ratio to the third, and we're seeing we're getting 8. So you could see that we're getting out the first, the second, the third, and the fourth term by using AR square, A to the R, and stuff like that. But if you look closer, we're going to realize that there is a general formula, because for the first term we'll have R to the 0 basically. So for the first term we have A R to the 0, understand? So the power of R is 1 less than the first. For the second term we're looking at A R to the 1. You could see that the power of R is 1 less than the nth term, 2. For the third term, we're looking at AR square. The power of the ratio R is 1 less than the term we're dealing with, the third. And we could just stop at the fourth term because it's AR to the third. So you could see that the power of the ratio is 1 less than the fourth term here, 4. Now, generally speaking, what if it is the nth term? Well, for the nth term, we're looking at nth term. We're looking at A R to the n minus 1. So as you could see, this would have been what we can use to come up with the nth term, based on the fact that the power of the ratio R is 1 less than the nth term. So AR to the n minus 1 would give us that general formula that we need. All right, thank you for watching. You could look out for more videos on AP and GP. This is the first, which is the introduction. So there's another video coming. where we'll be solving problems in AP and GP. Thank you for watching.